In the last video, we wrote some algebraic expressions from some word phrases that are easily translated into math, and we called these types of word phrases math speak. Now in the problems that we'll see in this video, it will require a little more thinking to be able to write an algebraic expression. It won't be a word phrase, but more like a paragraph, and the required information won't be as nicely pieced together as with math speak. I call this real-world algebra because these are types of problems that come up in real-world situations and not just math class. Other people might call these word problems, but however you want to call this, we're going to write some expressions for the situations presented. So let's get right into it. So the situation we have here says that from the time of her 13th to 14th birthday, Sarah gained 10 pounds. The LBS there standing for pounds. And if she weighed X pounds on her 13th birthday, how much does she weigh on her 14th birthday? Alright, so with problems like these, we need to first find the important information and what we need our expression that we're going to write to represent. So here it might help to start with what we want our expression to represent. This you'll usually find in the last sentence of the paragraph, and that's the case here. It asks us to write an expression for how much Sarah weighs on her 14th birthday. So that's what we need to write an expression for. In this problem, her weight changes with time from her 13th birthday to her 14th birthday, and we know how much she weighed on her 13th birthday, and we know how much she gained in between her 13th and 14th birthday. So we should be able to write an expression for her weight when she turns 14. So we see her weight on her 13th birthday was X pounds, they tell us. X there being the variable to represent the number of pounds she weighed when she was turned 13. And in between her two birthdays, she gained 10 pounds. So this is an example of a problem where we have a starting value and the amount that value changes, and we have to add those together to get an expression to represent the end value. So here the value that we're talking about is Sarah's weight, and it starts at X pounds and it changes by 10 pounds. So we just have to add those two together to get her weight when she's 14, and of course add the LBS at the end. That's called the units, and always important to include the units. But anyways, this is our final expression here that represents how much she weighs on her 14th birthday. Now I know this might have been a long explanation for something that you might have thought was pretty easy, but I'm just trying to give you guys a better explanation of what you're doing instead of just instinctively following a procedure. But anyways, I have a follow-up on this problem. This says, on her 14th birthday, Sarah compared her weight to the weight of her older brother and found that he weighed twice as much. Write an expression for the weight of Sarah's older brother. So this is the same situation as the previous question. Same Sarah. We already know her weight when she turns 14. That's just X plus 10 pounds when she's 14. Sarah. And we're asked to write an expression for the weight of Sarah's older brother. So that's what we're trying to write an expression for. In this problem we have one value, Sarah's weight, and we have another value, her brother's weight, and we know how these two values compare. It says that her brother's weight is twice as much as Sarah's weight, twice being a code word for multiplied by 2. And we're asked to write, as I said before, an expression for Sarah's older brother's weight. So we take Sarah's weight when she's 14, and we multiply that by 2, and that should give us an expression to represent brother's weight. So Sarah's weight, and this is asking us on her 14th birthday, which we found in the last problem to be X plus 10 pounds, and we're going to multiply this by 2. I could write this more aesthetically pleasing way by the commutative property, of course, and put 2 in the front there. Same thing, but whatever you do, you want to make sure you multiply the 2 by the whole x plus 10 pounds, not just by the x, because the x plus 10 pounds is the expression that represents Sarah's weight, at least when she's 14, and we're multiplying that whole thing by 2, so we have to multiply the whole x plus 10 pounds by 2. And we can distribute this out if you like, using the distributive property, of course, to get 2x plus 2 times 10 equals 20. 2x plus 20 pounds is the weight of Sarah's older brother. Let's do another one. So a certain skyscraper in New York City is z feet tall. Write an expression for the height of the skyscraper in inches. In this problem, we have to convert between units. So this problem actually doesn't give us everything we need to know to write an expression. There's some outside information that they expect you to know, and that is the conversion between feet and inches. Hopefully, if you live in the US at least, maybe not in other countries since they don't use inches and feet, you know 12 inches is just 1 foot. So that's what we need to know there. Hopefully you knew that already. But here we're going to have just a given value, and the value that we're writing an expression for, they don't change. It's just the height of the building. The one thing that does change is the units, which hopefully illustrates how important units are to include in your expression. So how can we go about writing this expression? Well, let's first write what we know. We know that the height of the building, if we're trying to write an expression for it, is z feet. And now we're still trying to represent the height of the building, but in inches. So we have to find a way to take this feet and put it into inches. Now we can't just say feet, cross it out, put inches, z inches. Nope. Because that would be completely ignoring the conversion between inches and feet. We know that z feet wouldn't be the same as z inches. So what we have to do is use our conversion here to get this into inches. Now you can think of this as being z times 1 foot. So you just multiply the z and the 1 together and leave the units alone. So if, say, z was 100, it'd be 100 times 1 to get 100 feet. So what we can take here is this 1 foot and cross it out and put in 12 inches, because that's what we know to be equivalent to 1 foot. And then just drop the z down there. So now it's z times 12 inches, which we could write also as 12z to put the coefficient in front and the variable in back. So our final expression for the height of the building is 12z inches. That's all I'm going to do for this video. I want to work more on problems like these, but I don't want a 15-minute video, so I'll just push it back into the next video. So I'll see you guys next time, and we'll write some more expressions like these.